binary number, you can able to perform various kind of arithmetic operations, right? Arithmetic operation, right? You are going to have binary addition, like plus is there. Similarly, binary subtraction, minus, and you can able to perform multiplication also. Multiplication. You can able to perform binary division. So like this, there are binary arithmetic operations that we can able to perform on binary numbers, right? As usual, like what we are trying to do in decimal digits, like as our normal format, we can able to perform all in binary numbers also, right? So for example, if you try to observe here, I will take simple example, like two numbers. One binary number is assuming that A, another binary number is B. So how many possible values are you going to get? 0, 0, 0, 1, 1, 0, 1, 1, right? On these two numbers, I am going to add addition, binary addition operation, right? So 0 plus 0 is what? 0. 0 plus 1 is 1. Okay. 1 plus 0 is 1. What is 1 plus 1? 1 plus 1. If you observe here, I have added 1 plus 1 is 1, 0. 1, 0. Meaning that your result is going to be 0. Meaning that this will be sum. This will be sum. When you are trying to perform addition, your sum will be 0 when you are trying to perform 1 plus 1, 0. And for every operation, carry also will be generated. Carry also will be generated, right? So when you are trying to perform 0 plus 0, 0, carry 0, 0 plus 1, 1, carry 0, 0, 1 plus 0, 1, carry 0. When you are trying to perform 1 plus 1, what is 0? Normal result is 0, carry is 1. This is what you have to observe. Okay. Similarly, these two are related to sum. When you are trying to perform subtraction, you are going to get actual data subtraction, and similarly, you are going to get carry also, right? So when you are trying to perform 0 minus 0, 0, okay, don't worry about this 0 minus 1, okay, later part will do. 1 minus 0 is what? You know, the direct 1 minus 0 is 1, and 1 minus 1 is 0, right? When you are trying to perform 0 minus 0, is there any carry required? So if you observe the basic terminology of mathematics, this should be like borrow. Is there any bar required when you are trying to subtract from 0 minus 0? No. When you are trying to subtract 1 minus 0, right? 1 is bigger value than 0, so you don't need to have any borrow. 1 minus 1 is both are same, so there is no need of taking any borrow. But when you are trying to perform 0 minus 1, compulsory you have to take borrow from the other side. Compulsory you have to take borrow from other side. So that's why here you will get 1, and here you have get 1. 0 minus 1 is 1, and that borrow also will be taken, right? If you observe somewhere, right, simple thing, if you are going to do 1, or else let me write here itself, 1 0 minus 0 1, 1 0 minus, right? When you are trying to perform, so 0 minus 1, it is not possible, so your result you have to take borrow from here, so that here you will be got 1. So now 0 minus 1 is 1. Now if I give borrow here, this value will be 0. 0 minus 0 is 0. Okay. So if you observe in terms of decimal number, what is 1 0? 2. What is 0 1? 1. 2 minus 1 is 1. Right. What is the residual 0 of 1? Which is equal. Right. Like this. Right. Similarly, when you go for multiplication, also you can do multiplication. On multiplication, if you try to perform a star b, here also there is a chance of getting carry or not. Yes, there is a chance of getting carry, because when you are trying to perform multiplication, yes, sometimes you may get. So what is a 0 into 0? 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. 1 into 1 is 1, right? Guys, will the carry will be get here? No. Because if you are going to multiply two binary numbers, the possibilities are only these, right? When 1 into 1 is 1, right? It is a rule of identity property. x into x is x only. Okay, so that is what, yeah, right? Similarly, if you go for division property, a by b, right? So what is 0 by 0? See, when you are going to perform, when you have divisor as 0, then you cannot able to define the result. That is, right? Divisor as 0, result is undefined. So when the divisor is 0, result is undefined. When the divisor is 0, result is undefined. What is 1 by 1? 1 will be remove how many times from the numerator? 1 time. What about 0 by 1? If you take 0 by 1, 0 by 1, or else if you take the normal procedure, 1 zeros 0, 0. So you are going to get 0 as a reminder. Right? So this is what you have to know, right? Right. So let me take a few examples so that you will get clear idea how the binary addition is going to happen and all those things, because you are getting sometimes confusion over how to perform three ones, or sometimes you may get four ones more, sometimes 1 1 1 1. So at the time what you have to do, so this is what the confusion, right? So this is actually 1 plus 1 is 1 0. For that, if you add 1, you will get 1 1. For that, if you are going to add, you will get 1 0. If you are 1 1 1 0, so your result will be 1 double 0. So your result will be 1 double 0 when you are going to add 4 ones. At the time, what will happen? First 0 will be carried to next immediate number. Next 1 will be carried to next super carry. This is what you have to understood, right? So that's the reason I will take the simple examples here. Okay, fine. So for example, I will try to perform addition of 9 and 11. Addition of 9 and 11. So 9 is like 1001, 1001. 11 is like 1011. If you are trying to perform addition, 1 and 1 is 1 0, 1 and 1 is 1 0, 0 and 1 is 1, 1 and 1 is 1 0. So 1 0 1 0 100 is the answer. So which is equal to 20, right? If you observe, this is 16 plus 4 20. This way. So this is a simple thing. Simple thing. Okay, fine. So if you observe the negative part, like negation, for example, let me take 6 minus 3. 6 minus 3. Okay, if you are trying to take 6 minus 3, what is the binary value of 6? 110. 110. What is minus 3? Guys, here you may get confusion, right? This minus 3, you can repeat it in 2's complement, right? 2's complement. Okay, so then you can go, we can able to go with for the purpose, right? So for time being, what I will do now, I will try to represent this 6 also in 2's complement, 6 also in 2's complement, and I think this is 6 only. 4 plus 2 is 6. In minus 3, minus 3 is 2's complement is what? So double 0 double 1. For this double 1 double 0, if you add plus 1, this is 2's complement. Double 1 0 1. Right? This is minus 8 and minus 5. That is minus 3. Right? Double 1 0 1. If you are going to add 0 plus 1 1, 1 plus 0 1, 1 1 is 1 0, 1 1 is 1 0. 1 1 is 1 0, right? So now here you got as carry. When you got as a carry as 1, then what you can do, you can simply uh, this carry will be discarded, so your result is going to be plus 3. Guys, you can observe the formulas. See, I would like to discuss only here b minus, a minus b, but I am trying to discuss, which is already. I am trying to perform subtraction in many forms, right? One is b minus 1 complement, another one is b's complement also. Another one is b's complement. So when you are trying to perform b's complement, I think I have given all these formulas, right? We go with right. So observe, When you are trying to perform b minus 1's complement, you have to go with the b minus 1's complement of the subtract, and if the carry is generated, add result back to the result. That will be the final result. If doesn't carry, you have to make complement, you have to add minus. When it is performing b's complement, you have to take the b's complement of the subtractant, and you have to perform the negative operation. That is, if the carry is generated, it should be discarded. If the carry is not generated, complement, and you have to add minus, right? In our case of 2's complement, carry is generated, so you have to simply discard. You have to simply discard, right? As carry generated, simply discarded, right? So this is what the logic. So in b's complement, if carry generated, we are going to simply discard. If no carry, we are going to make complement, and we are going to add simply minus. Whereas in b's minus 1's complement, if carry generated, we are going to add to the result. We are going to add to the result. If no carry generated, we are going to simply making of complement, and then we are going to add minus, right? This is the general procedure. See, this procedure will work for everything, right? As I'm trying to work with 2's complement, as if the carry is generated, see here I have added plus 1, right? Plus 1 I have written, meaning that I am trying to have 1's complement plus 1, so this will be the 2's complement. So the result is plus 3. But here my point is how to perform negation over subtraction over a and b, right? So if I am going to have 6, that will be represented as 0 1 1 0, 3 as represented as 0 0 1 1. Now on these binary numbers I would like to subtract. That is what, right? So I have mentioned directly. What is 0 minus 1? You mentioned 0 on 0 minus 1, you have to make subtract 1, and you have to take it borrow. So 0 minus 1 is 1. So now here what will happen? Here 0 will be there. Here 0 will be there, right? As this will be given to here. Now again I need to take borrow. 1 borrowed. 1 minus 1 is, so see here it will be 0, right? So you have to take borrow. 0 minus 1. Now 1 0 minus 1 is, again you are going to get 1. Now here there will not be anything, right? 0 minus 0 0 0. So 0 0 1 1. 0 0 1 is 3 is the answer. Okay, fine. So take out another number. 5 minus 2. 5 is 1 0 1. 2 is 0 1 0. 1 minus 0 is 1. 0 minus 1 is 1. And 0 here 0. So this will be equivalent to plus 3. This way you are going to perform subtraction. Okay. Similarly, when you are trying to perform multiplication, for example, let me take two numbers, 4, another number is 6. So this is 4, this is 6. Right? So what you are going to do? 0 multiply with 0, 0, 0 multiply with 0, 0, 0 multiply with 1, 1. Sorry, 0 multiply with 1, that is 0. When you are trying to multiply 1 with all, you are going to get 1 0 0. As usual, like normal multiplication only. 1 multiply with all, you are going to get like this: 0 0 0 1 1 1 0 0 1 1 0 0. Right? What is this value? Right? I think 1 2 4 6 1, sorry, 1 2 4 8 16. 16 this is 8. 16 plus 8 is 24, which is equivalent to 4 into 6 24. 24. Okay. If you want, let me take one more example. 1 0 0 1 multiply with 1 1 1. What is the value? This is I think 9. This is 7. Total you should be get 63. 9 7 is 63, right? So when you are trying to multiply with 1, so this will be 1 0 0 1. This will be 1 0 0 1. This will be 1 0 0 1. 3 times of same thing. 1 1 1 1 1 1. So total is 63 only. So like this you can able to perform multiplication. Similarly, if you take division of two numbers, for example, I am trying to take two numbers 1 0 0 1 0. What is 1 0 0 1 0? So 1 2 4 8 16. 16 plus 2 18. So can I possible to divide with 3? Yes. 3 is like So your result should be 6 mark. The result should be 6, right? So guys, try to observe here. Observe here. Is 1 1 will it be subtracted? Is it possible? No. So what we can do now? We can take uh, 1 0 here, and then you can add one more. See, basically first we have to check with the, it's like a basic operation. 18 3, right? So when 18 3, first I will take 1. Is it possible to divide 1 with 3? No. So what I will do, I will take 0 here. Then I will get the remaining also, that is 8. So 3 6 are 18, your remainder is 0. So 0 6 will be equivalent to 6 only, right? Similarly, first try to take out this 1. Is zeros, it will be like subtracted? No, it is not possible. So next I will take one more 0. One more 0 from 10. Will it be happen to subtract 11? No, it won't be possible. So then it will take one more 0. Then you are going to get 100. 100, like 100. From 100, if you are going to get like 11 subtraction, can you do that? Yes. No. So 100 minus double 1. So 0 minus 1 is 1. 0 minus 1 is 1. Now here it should be 1. See, this will be comes here, right? As here there is no value, it is going to be taken from here, right? Now here it will be 0. It will be 0. Here it will be 1. Here it will be 1, right? So 1 minus 1 is 0. So there is 1 already here. 1 minus 1 is 0. 0. Now I will take out one more thing. 0 double 1, right? 0 double 1 is 1 1 1. You are going to get 0, right? Next you will get 0 zeros 0. So your result is 0. So you can stop, right? So this double 00011 will be acted as number 3. So what is the result you need to get here? So here it should be like 0. So 3 6 are 18. Okay. So if you want, I will take one more example, simple one. So let me try to divide 101 with the 11010. Don't get confused. So if can I perform subtraction if I write like this? 101 is 110 is bigger than 101 or not? Yes. So 101 ones are 101. So 0 minus 1 is 1 1. So here what will happen? 0 is there. 0 minus 0 is 0. This is 0. Now I will try to do one thing down. As usual. Now is it possible to subtract? No. So then I will take 0. Then I will get once again 0. Now is it 101 ones are 101. 101. So you are going to get I think 0 minus 1 is 1. 0 minus 0 is 0. 0 minus 0 is 0. So total this one is the result. Right? What is this value? You can able to convert. Okay. Next, take the next number 100 100 110 right? So is it directly subtracted? Yes. 100 100. So you are going to get here triple zeros. So we can neglect all this. So now you can get automatically 1. Automatically 1, right? Now next, to get 2 more ones, you have to add 2 zeros. So, 2 more ones. 1. Now you can get as 100. 100. If you remove this, now you will get 110. 110. From this 110, can you able to subtract? Yes. Ones are 100. That is 10. 10, right? From 10, now if you would like to add one more 0, can you go with the dot? You will get one more 0. You can get 1s are 100. You are going to get the remainder as 0. So like this you can able to perform subtraction. Okay. Division. I hope you understood clearly. Okay.